So as we've said here, a quadratic equation can be written in the form ax squared plus bx plus c equal to 0. If we can write our equation in this form, then this is defined to be a quadratic equation, and we will know with absolute certainty that it is a quadratic equation. But we can't know that until we have each of the terms listed. In other words, there are no parentheses involved. If there is parentheses, if there is multiplication involving parentheses, we need to get rid of that. We need to expose each of the terms in the equation. We need to combine like terms when possible. And we need to get the equation set equal to 0. In other words, all of the terms need to be moved on one side of the equation or the other. Here they have all the terms moved to the left side of the equation, and they have it set equal to 0 where 0 is on the right side. Now that can be switched around. You could rewrite this as 0 equals ax squared plus bx plus c. It doesn't matter which side you have. The big thing there is a cannot equal 0. If a is 0, 0x squared is redundant, you don't write it, and you no longer have a quadratic equation. You will have a linear equation. So understand that the b and c coefficient values, they're allowed to be 0. But if the a value is 0, then we don't have a quadratic equation. So our guidelines here, write it in general form. In other words, we want to have the largest exponent first, followed by the next largest. We then want to look to, and of course, have our equation set equal to 0. We then factor our polynomial expression, set each factor equal to 0, and then solve each of the equations here or thereafter. Check our solutions in the original equation. Remember that to solve an equation involving x means to find all values of x that satisfy the equation. For the linear equation, the goal is to isolate x by rewriting the equation in the following form: x equals some number. So in other words, once we factor our polynomial and set each factor equal to 0, you will see that each factor set equal to 0 typically looks like a linear equation, and we'll use our methods for solving the linear. So our first example here, we will solve the following quadratic equation. Our equation here is 2x squared plus 5x equals 12. So let's think here about what we have. We have two terms on the left side of the equation. We have one term on the right. That one term on the right is 12. That's a constant. That is the c value for our definition of a quadratic equation. However, what do we notice here? This equation is not set equal to 0. We have the ax squared plus bx on the left side. We just need the c value. So to get this set equal to 0, we want 0 on the right-hand side. We don't want 12. How do you get rid of 12? Subtract it off. Subtracting 12 on each side of the equation, we get the following equation in general form: 2x squared plus 5x minus 12 equals 0. So subtracting 12 on each side, 12 minus 12 on the right becomes 0. Subtracting 12 on the left side, we do not combine that subtraction of 12 with our terms because they are unlike. So we will simply write the operation of minus 12 at the very end. Therefore, we have our quadratic equation where for ax squared plus bx plus c, our value of a is 2, our value of b is 5, and our value for c is negative 12. So now we will look to factor our polynomial, and in this case, our trinomial, by using our AC method that we learned in section 3. So we'll go to the full board here. Before we can obtain our solutions, we need to first factor our trinomial. Now that the trinomial equals 0, we do not have to focus on that equation any longer. Let's look at the trinomial as an expression and only focus on these three terms. Going back to 6.3, to factor a trinomial of this form, we use our AC method of factoring. We start by multiplying a and c. 2 multiply negative 12. Our second step is to find two integers whose product is negative 24 and whose sum is positive 5. Let's think about that. Two numbers that multiply to give us a negative number but will add to give us a positive number. Think about all the factors of 24, 1 and 12, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those integer pairings will multiply to give us 24. But how can we introduce them in such a way that the product is not 24, but negative 24? And for those two integers, when you combine them, we get positive 5. Well, we are going to use positive 8 and negative 3. Because 8 multiply negative 3 is negative 24. 8 plus or combined with negative 3 is positive 5, right? 8 minus 3 is 5. 8 times negative 3 is negative 24. So reversing those FOIL steps, we're going to use these two integers to rewrite this middle term here. As we see, this still represents the same exact equation because 8x minus 3x is 5x. Only we are reversing it because, again, we're trying to factor this and set each factor equal to 0. To factor here, now that we rewrote this 3 terms as 4 terms, group together the first 2 terms to determine a greatest common factor. Here's x squared, here's an x, so we can factor out an x. Well, look at the coefficients. We have a 2 and an 8. 8 is actually a multiple of 2, right? 8 is 2 times 4. So there's a factor of 2 here. There's a factor of 2 here that can be moved out. So the greatest common factor for these two terms, 2x. When you factor out a GCF, introduce parentheses to determine what you leave behind. This is 2 times x squared. This is 2 times x. So we leave behind simply one factor of x. 8x, factor out a 2x is the same as dividing it out. If you have 8x and you divide out 2x, well, here's the factor of x here, and we moved it out front. 8 divided by 2 is positive 4. 2x multiply x is 2x squared. 2x multiply 4 is 8x. That all checks out. Now, what about the second two terms over here when we pair them together? We notice they are both negatives, so we want to pull out a minus sign. Moreover, we see that this 12 does not have a factor of x. This one does, but we cannot factor out an x because this one doesn't have it. So looking at the 3 and the 12, 12 is actually a multiple of 3. What do we mean? Well, if you take 3 and multiply it by 4, you get 12. So 12 actually has a factor of 3. Of course, the 3x has a factor of 3 because the 3 is multiplying an x, making 3 a factor. Not only are we going to factor out a 3, we're going to factor out a negative 3. Introduce parentheses to determine what you have left behind. Well, if I take this negative 3 and move it out front, I'm only going to leave behind that x. If I have a negative 12, but I take out a negative 3, negative 12 divided by negative 3 is positive 4. We, of course, can confirm this. Negative 3 multiply x is negative 3x. Negative 3 multiply positive 4 is negative 12. Note, these binomials are exactly the same. For the AC method of factoring, if you can find those two integers that will multiply to give you AC, that will add to give you B, you are guaranteed to be able to factor the trinomial. The x plus 4 common binomial factor, it's factored out front. When you factor, introduce parentheses, determine what you leave behind. 2x minus 3. This x plus 4, multiply this 2x minus 3 equals 0. So we get to familiar territory here. We have the product of two algebraic expressions. The x plus 4 expression is multiplying the 2x minus 3 expression. And that product equals 0. So the 0 factor property will allow us to take x plus 4 and 2x minus 3. Notice that they had theirs in a little bit different of an order. That's perfectly okay. Multiplication is commutative, so we are allowed to interchange those expressions, right? 2 times 3 is the same as 3 times 2, so we're good. But now, what have we been able to do? We factored our trinomial once we moved the 12 to the left side by subtraction. We factored our trinomial. We now have the product of two expressions equal to 0. So we will set each factor equal to 0 and solve, according to our guidelines for solving quadratic equations. So the x plus 4 factor, set equal to 0. The 2x minus 3 factor, we will set equal to 0. what number plus 4 equals 0 to get x by itself? We're adding 4, so let's subtract 4. So we get a solution of -4. Of course, -4 plus 4 is 0. And of course here, -4 plus 4 makes this 0. And 0 times any number is 0. We confirm that solution. What about right here? To get x by itself, x is multiplying 2 and subtracting 3. Let's start by adding 3 to get rid of that subtraction. Have to balance it out. X is being multiplied by 2, so we divide it off, because dividing is the opposite or the inverse of multiplying. Of course, 2 divided by 2 is 1, and if you have 1x, you simply write it as x. X is 3 halves. Is that a solution? Well, 3 halves is the same as 1.5. 1.5 times 2 is 3. 3 minus 3 is 0. 0 times any number is 0. Another way to think about this, 3 halves times 2, well, the 2 in the denominator, multiplying the 2 will cancel, leaving us with simply 3. 3 minus 3 is 0. Once again, confirming our solution of 3 halves and -4. We'll go back to the PowerPoint, and we'll see those solutions that they get for us there. So we'll go ahead and go on and look at some examples here. In the following exercises, let's look to solve the equations by factoring. We'll give you problems 26 and 27. Note that we already have the equation set equal to 0. That's very nice of them to do that for us. But in any case, if it's not set equal to 0, we want to get it set equal to 0. Now that it is, we will look to factor the polynomial expression x squared minus x minus 12. It may not be factorable. If it's not factorable, we will discuss later methods of solving equations by the quadratic formula. You can always rely on the quadratic formula for solving equations, but sometimes it's just easier to be able to view a trinomial as factorable because the factors will allow us to further investigate our functions and investigate our equations. Looking at number 26, for x squared minus x minus 12 equal to 0, if we can factor this, note that this x squared doesn't have a number in front of it. It's understood to be 1. So this takes us back to section 2 of chapter 6. It says, if that leading coefficient is a 1, just ask yourself this simple question. Can we find two numbers that will multiply to give us -12? Because this is our value of c. Right, that's what our c is here, the x squared plus bx plus c. But these two numbers that multiply to give us -12, can we find these two numbers that will also add to give us our b value, which in this case is -1? So if we can find the two integers to do this, then we're guaranteed for this to be factorable. Well, what are multiple, or what are factors of 12? 1 and 12, 1 times 12, 2 times 6, 3 times 4. Can any of those in any way combine to give us 1? Because if we multiply to get a negative, one of these factors has to be negative. A negative times a positive is a negative. So -1 times 12, maybe 1 times -12, -2 times 6, 2 times -6, -3 times 4, 3 times -4. Those are our only options. And it turns out 3 multiplied -4 is -12. 3 plus -4, which is the same thing as 3 minus 4, is -1. So we found the two integers. And because, again, this leading coefficient is 1, you're going to get an x here and an x here, because x times x gives us x squared. Now, what will multiply to give us -12 in such a way that it will combine to give us -1? The plus 3 and minus 4. Because as we see, our inner product will give us the plus 3x. Our outer product will give us the minus 4x. An inner and outer product, that's why we ask. Two numbers that will combine, notice here we're going to combine these two now to give us the middle term. Plus 3x minus 4x is minus 1x. In such a way now that when we multiply the last terms, 3 times -4 is -12. So this confirms that we correctly factored our trinomial. Now that we have our trinomial factored and the factors equal 0, right, the product of this factor and this factor, x plus 3 multiply x minus 4, equals 0. So zero factor property says set each factor equal to 0 and solve. So again, x plus 3 equals 0. To get rid of the plus 3, we subtract 3. We're subtracting 4 to get rid of the subtraction of 4, we add 4. 0 minus 3, 0 plus 4. So we obtain our solutions. Negative 3 is a solution, 4 is a solution. We can confirm that by plugging them in. Negative 3 when squared is positive 9. Negative 3 times negative 1 is positive 3. A positive 9 combined with positive 3 is positive 12. Subtract 12 is 0. That checks out. What about 4? 4 squared is 16 minus 1 times 4. Well, that's 16 minus 4, which is 12. And then 12 minus 12 is 0, confirming our solutions, negative 3 and 4. And we get two solutions to our quadratic equation. Keep this in mind here. Something neat about this. A quadratic equation, the largest exponent for the variable is 2. So what does this mean for our solutions? It means that we're not always guaranteed to have two solutions. It's possible that an equation may not have a solution at all. But what's neat for quadratic equations is they can have two solutions, they can have one solution, they can have 0 solutions, or they can have an infinite number of solutions. But those are the only options. 0 solutions, 1 solution, 2 solutions, or an infinite number. You can't have 3, 4, 5, or 6 solutions. Either every number satisfies this equation, no number satisfies it, or one solution or two solutions. It's interesting thing about polynomials. The largest exponent tells you how many possible solutions you may have if there is a finite number of solutions. For number 27, we have x squared minus 10x plus 24, and this equals 0. And we're being told to solve the equation. So again, here we see that we have our trinomial, our three terms here set equal to 0. This is defined to be a quadratic equation. Ax squared plus bx plus c equals 0, where a is understood to be 1, b is negative 10, c is positive 24. Now, because the a is equal to 1, it's a very nice, easy trinomial to factor. Just ask ourselves the questions, what two numbers multiply to give us positive 24 that will also add together to give us negative 10? As we see, we're just trying to think, when we do the FOIL method, what is that outer product and inner product's coefficients? Those are going to be the two integers here. They're also going to be the two numbers that multiply to give us positive 24. So two numbers that multiply positive combine to get negative. Both numbers have to be negative. There's no way around it. A negative times a negative is a positive. A negative combined with a negative is a negative. So what are those two integers? If we can find them, then we're guaranteed for this trinomial to factor into the product of two binomials. Because keep in mind, there is no GCF here, right? There is no greatest common factor. I can't factor an x out of all three terms. And with this coefficient of 1, 10, and 24, I cannot factor anything out common. What times what gives me x squared? Well, that's x times x. And now what are these two terms going to be here? Well, it's the two integers that we're trying to work with up here. Minus 6 and minus 4. And it doesn't matter which order you write it in. We see that a minus 4 multiply minus 6 is positive 24. A minus 4x combined with a minus 6x is minus 10x. So we found the two factors that multiply to give us our trinomial. Therefore, we factored our trinomial. And now the zero factor property says we can set each of the factors equal to 0 and solve for the variable. So what number take away 4 is 0? Well, that's 4. We get that by adding 4 to each side and isolating the variable x. After the negative 4 and positive 4 cancel on the left side, combining 0 plus 4 to get 4. Similarly with this one here, adding 6 to each side, we find two solutions of 4 and 6. Very quickly, can we check them? Plug 4 in. 4 squared is 16 minus 10 times 4. Well, 10 times 4 is 40. 16 minus 40 is negative 24 plus 24 is 0. 4 is a solution. What about 6? 6 squared is 36. 10 times 6 is 60. 36 minus 60 is negative 24 plus 24 is 0. We've confirmed our two solutions here. Our solutions are 4 and 6. Looking at number 19, 5y squared, so that's 5 multiply y squared, equals 15 multiply y. We're being told to solve the equation. We see that the term on the left-hand side has the exponent of 2. So we do have a quadratic term here. We have a term with exponent 2. So we're not going to solve this by isolating the variable. We have two terms that have the variable y. So what do we want to do here? Well, according to our rules for solving polynomial equations, our first step here is to get the equation set equal to 0. Now we see that the y squared term is on the left-hand side, and that's the largest exponent we have. So we're going to leave that there on the left-hand side. We will take the 15y and move it to the left side. Now we can't just pick it up and set it over there. We will use our properties of equality. The 15y is understood to be a positive 15y. So to get rid of it on the right-hand side, we subtract 15y. And we do so on both sides of the equation. So on the left-hand side, 5y squared minus 15y. Well, this is going to equal 15y minus 15y, which of course is 0. So now just subtracting the 15y, moving it to the left-hand side, we have our new equation, 5y squared minus 15y equals 0. So we see that our expression equal to 0 will now allow us to try to solve by factoring. You cannot begin factoring until your equation is set equal to 0. That is a must. That is your first step, is to get it in general form, which includes getting it set equal to 0, as well as making sure your exponents are from largest to smallest. Now, looking only at this left-hand side of the equation, the expression, our binomial, 5y squared minus 15y, is there anything common? Are there common factors? Things that are multiplying in each of the two terms that are the same. 5 is multiplying y squared. Well, what is y squared? Y times y. 15 times y. So there is a common factor of y that we can factor out. But is that all that's common? We factor out one factor of y. Now we look at the coefficients 5 and 15. 15 is a multiple of 5 because 15 is 5 times 3. Right, we know that 5 times 3 gives us 15, so we can factor out the common factor of 5 as well, because we see that 5 is multiplying here and it's multiplying here. It's just hidden. 15 times y is 5 times 3 times y, so we move out the common 5 and the common y. 5y squared, but we factored out 5y. What did we leave behind here? Just one factor of y. Right, that's how we can visually see 5y squared. 5 times y times y. There's the 5y, leaving behind the y there. Minus? Well, we had 15y, but we factored out 5y. So we took that 5 and we took that y and moved it out front, and we left behind the factor of 3. And of course, that makes sense because factoring is like the same as division. Remember, factoring is the opposite of multiplication, so we can view it as division. 15y divided by 5y is 3. And we can see that y because 15y divided by 5y, well, the y's cancel, and 15 divided by 5 is 3. And why is it 3? It's because 15 is 5 times 3, and the 5's cancel, leaving us with 3. We factor out our GCF of 5y. So what do we see here? The product of 5y and y minus 3 is equal to 0. So because we rewrote our expression as the product of its factors, and the product of its factors equals 0, zero factor property says we can set each factor that involves the variable equal to 0. See, we don't want to set 5 equal to 0. What happens there? This is simply a mathematical statement that is not true. 5 equals 0 is not true. 5 does not equal 0. So setting 5 equal to 0 doesn't help. So we're going to set the variable factors equal to 0. 5 multiply y minus 3. So setting the factor of y and the factor of y minus 3 equal to 0, we can obtain solutions. Our first solution is 0. It says y is 0. Lastly here, if y minus 3 is 0, adding 3 to each side, we find that we have a solution also that y equals 3. Now, of course, we can check these solutions by plugging them back into our original equation. The original equation was 5y squared equals 15y. Let's use that equation to check our solutions of 0 and 3. So go back to the full screen here. If y is 0, we see that on the left-hand side, 0 squared, which is 0 times 0, is 0. And so 5 times 0 squared is 5 times 0, which is 0. On the right-hand side, 15 multiplies 0 is also 0. So we get that 0 equals 0. That is a true statement. Therefore, x equals 0, or in this case, y equals 0. That is, in fact, a correct solution. We just confirmed that. Let's check the solution of 3. If y is 3, do we get a true statement? On the left-hand side, 5 is multiplying 3 squared. Well, what is 3 squared? It's 9. 5 is multiplying 9, and 9, 18, 27, 36, 45. On the right-hand side, 15 times 3. Well, 15 minutes times 3 is 45 minutes. We see here that when y is 3, we get a true statement that 45 does in fact equal 45. This confirms our two solutions. That y is the set of solutions 0 and 3. For number 31, 7 plus 13x minus 2x squared equals 0. Our trinomial is set equal to 0. However, it's not in the general form because our largest exponent is not written first. We see that the x squared is the largest exponent, so we want to write minus 2x squared plus 13x plus 7 equals 0. We get it in the standard general form. Largest exponent first, followed by the next largest, and of course this is set equal to 0, so now we can look to solve by factoring. First thing we notice, as we've seen, when the leading coefficient is negative, to make our factoring a little bit nicer, a little bit cleaner, and to expose the negative factor, if the leading coefficient is negative, we will factor out the negative sign. Only factoring, of course, the trinomial on the left-hand side. When you factor out a negative, you are changing a sign for each of your terms. Now, we have a trinomial inside parentheses that we will look to factor using the AC method of factoring, where A is now understood to be 2, B is understood to be negative 13, and C is understood to be negative 7. So AC method, multiply A and C. 2 and negative 7 multiply to give us negative 14. So now we want to find two integers that we can use to break apart this middle term. Two integers that multiply to give us negative 14 that will combine to give us negative 13. Negative 14 multiply a positive 1 is negative 14. Negative 14 combined with positive 1 is negative 13. So we found our two integers, negative 14 and positive 1. So we will use those to break apart this middle term here. Minus 14. So again, we see that these two terms we can always combine to give us back this term, but we're looking to factor, so we don't want to do that. We'll group together the first two terms, group together the last two terms, and find a GCF for these. For the first two terms, 2x. Factoring a 2x out of 2x squared, factoring a 2x out of negative 14x, And of course, we can check this by distributing back through to get with what we started. Now note here that we left behind x minus 7. And of course, according to our rules of factoring, whatever we factor out of these two terms, our remaining binomial must match this one here. This here, x minus 7, is exactly this right here. So what could we factor out of x minus 7 to ensure whatever we leave behind is x minus 7? We'll just factor out a 1. Because as you see here, what's the only thing that we can factor out of this? A 1. That's the only thing that these two terms have in common. I factor out the 1, which is understood to be positive. I introduce parentheses. If I take this 1 and move it out front, I just leave behind the x. The negative 7 divided by 1 stays negative 7. And of course, all of this here, we have the negative out front. So I have a common x minus 7 factor that will get moved out front. The negative stays out front. The x minus 7 now gets moved out front. And what do we leave behind? 2x plus 1. So not only do we have two binomial factors, x minus 7 and 2x plus 1, but we also have a negative factor. So this here, if you had this factorization, this trinomial represents the opposite of the factorization. That's what the negative indicates there, some opposite value. But that's okay because what it's done, it exposes that third factor. Negative 1 is multiplying x minus 7. That's multiplying 2x plus 1, and this results in a 0. Zero factor property says set each of your factors involving a variable equal to 0 and solve for x. So we ain't going to set we ain't, right? We will not set negative 1 equal to 0 because negative 1 equal to 0 doesn't make sense. It's not true. Set x minus 7 equal to 0. And let's set 2x plus 1 equal to 0. Well, for x minus 7 equal to 0, adding 7 to each side, we obtain the solution x equals 7. Now what about for x multiplied 2 plus 1 equals 0? We subtract 1. And then we divide by 2. So x equals 7, and x also equals negative 1/2. We can check these solutions as well. Checking 7 will be a little bit easier. So for funsies, I'm going to check the solution negative 1/2 for number 31. So, and just learning to work with fractions because there's beauty in working with fractions. 7 plus 13x, where x is negative 1/2, minus 2x squared. We want to know if this actually equals 0. So we'll go to the full view. 7 plus 13x minus 2x squared, where of course x is negative 1/2. 13 times negative 1/2, well, this now becomes negative, positive times negative. And 13 times a half is 13 halves. Basically just taking this whole number here and multiplying it to the numerator, and then we'll have that division of 2. Here, we have to first start by squaring the negative 1/2, which is a positive 1/4. If you square a negative, it becomes positive. Squaring a 1 is 1. Squaring a 2 is 4. Negative 2 multiply 1 over 4 is negative 2 over 4. So 7 minus 13 halves minus 2/4. We want to know if that equals 0. Well, we know 2/4 here can simplify down to negative 1/2. 7 can be rewritten as the fraction 7 over 1. And 7 over 1 minus 13 over 2 minus 1 over 2, the denominators must be the same for us to combine. Here, 7 over 1, we don't have a same denominator. We need the same denominator. So 2 is the same as 2. Those are fine. We can combine those. If I have minus 13 halves and minus 1/2, how many halves do I have now? Minus 13 minus 1 is minus 14 halves. But what about this 7 over 1 right here? Well, to get this number to have a denominator of 2, I will multiply the denominator by 2, but I must also multiply the numerator by 2. That's how we build up fractions. We just introduce a common factor. Normally, we reduce or simplify by canceling a common factor. But in this case, we don't want a simplified fraction. We want to build this fraction to higher terms so that we can combine it with other fractions. In order to do so, we introduce a factor to our numerator and denominator. That factor is 2. Because we see here, if we multiply a 2 to the top and bottom, we now end up with a denominator that is the same as the rest of our denominators. That's the idea, that's the goal. So this 7, which is 14 halves, that makes sense. 14 divided by 2 is 7. This 7, subtract the 13 halves, subtract the 1 half. Well, 14 over 2 minus 13 over 2 is 1 over 2. 1 over 2 minus 1 over 2 is 0. Any number subtract itself is always 0. Likewise, 14 halves minus 14 halves is 0, thus confirming that negative 1 half is in fact a solution. If you plug in 7, you'll get the same thing. 7 times 13 is 91. 7 squared is 49 times 2 is 98. 7 plus 91 is 98. Minus 98 is 0, confirming 7 and negative 1 half to be our solutions. So we're looking at number 43. We have here the product of x and x plus 2. Subtract the product of 10 and x plus 2 equals 0. Now, as we've seen before, when you have parentheses involved, our first thought is to distribute. Distribute the x through to the x plus 2. Distribute the negative 10 through to the x plus 2. Now, be mindful here that what we have set up are actually two binomials. We have the first term, we have a binomial with two terms. The first term is x multiply x plus 2. The second term is the negative 10 multiply x plus 2. So what do we have here? We have a common binomial factor. The x plus 2 is multiplying the x, is multiplying the negative 10. That's common for both terms, so we can factor it out front. Moving the x plus 2 out front, what do we leave behind? We leave behind the x and the minus 10. So factoring out the x plus 2, we leave behind the x and the negative 10. That makes up our remaining polynomial. But what we see here, the product of our two binomials equals 0. Zero factor theorem says set each factor equal to 0 and solve. Setting each factor equal to 0, factors multiply, they're multiplying. Setting the factors equal to 0, solve for x. X plus 2 equals 0, therefore if we subtract 2 on each side, we isolate the variable, therefore finding the solution of negative 2. X minus 10 is 0, adding 10 to each side. We find our solution to be x equals 10. And of course, we can take each of these solutions separately and plug them into our original number 43. If we take 10, for example, x times x plus 2 is 10 times 12, which is 120. Plugging 10 into the second part, minus 10 times 10 plus 2, once again, that's 10 times 12, which is 120. 120 minus 120 is, in fact, 0. Negative 2, you plug it in. Negative 2 multiply negative 2 plus 2 is negative 2 multiply 0, which is 0. Plugging negative 2 into the right-hand side, negative 10 multiply negative 2 plus 2 is negative 10 multiply 0, which is 0. Of course, on the left-hand side now for number 43, 0 minus 0 is in fact 0, thus confirming our two solutions to be negative 2 and positive 10. Number 38, we have a squared plus 4a plus 10 equals 6. So on the left-hand side, we have a trinomial. On the right-hand side, we don't have 0, we have the number 6. Now, in order to solve this polynomial equation, more specifically this quadratic equation, we have to get it in a general form. We need it set equal to 0, not set equal to 6. We cannot solve this equation until we get it set equal to 0. So how do we do that? By subtracting 6 on each side of our equation. We see on the right-hand side, 6 minus 6 is 0. On the left-hand side, a squared plus 4a plus 10 minus 6. Combining the like terms, we will get a squared plus 4a plus 4. And we've actually seen this trinomial before, x squared plus 4x plus 4. Treating a, the variable, just like we do x, leading coefficient is 1. Our b value there is 4, and then our constant is 4. What two numbers will multiply to give us 4? That will also add to give us 4. If we can find those two integers, then we can factor this. Well, a times a is a squared. Now, what times what will give us 4 in such a way that the inner and outer product will combine to give us 4a? Well, what are the factors of 4? 1 multiply 4, but 1 plus 4 is 5. 2 multiply 2. 2 times 2 is 4. 2a, 2a. That will combine to give us the middle term, 4a. So we have our correct factorization. Moreover, you see that this is actually a special factor. This trinomial is a perfect square trinomial because, as you see, this results in the factorization of repeated factors. A plus 2 is repeated. We have 2 factors of a plus 2. So, of course, we know that we could rewrite this as the quantity a plus 2 squared. Now, when we get into quadratics and square roots, now we can just see that by taking the square root of each side, because we're squaring it. What's the opposite of squaring? What's the inverse? Taking the square root. We get a cancellation of the square root and the square, leaving us with a plus 2. And on the right-hand side, the square root of 0 is 0. Solving for a, we get the solution of negative 2. We're going to find that same solution if we just stay here. Zero factor property says, well, now that you have factored your trinomial, set each factor equal to 0 and solve for the variable. But notice that these factors are the same. So when I set this factor equal to 0, that will give me the same solution as if I were to set this factor equal to 0, because it's the same thing. So just by setting one of these factors equal to 0 and solving for a by subtracting the 2, we see here that we actually only get one solution for this quadratic equation, and that's okay. That happens at times. As we said before, quadratic equations typically have two solutions. They may only have one solution. Sometimes they have 0 solutions. The only other case is when there are an infinite number. In other words, no matter what number you plug in, you will get a correct solution. But in this case, you only get one solution, and that is negative 2. And you see why you get only one solution. It's because you get these repeated factors. And these factors, each of them will obtain the same solution of negative 2. For number 47, we have here that x is multiplying x minus 5, and this equals 36. So we got a lot going on here. We have, on the left-hand side, x is multiplying x minus 5, so we need to get rid of that. We have those parentheses there. And unlike number 43, we don't have a common binomial factor. We just have the binomial factor of x minus 5. So for number 47, on the left-hand side, we should distribute by multiplying the x and x minus 5. Let's start there first. Distributing this x through multiplication, x times x is x squared. X multiply negative 5 gives us the negative 5 multiply x. And this, of course, equals 36. Now, we see that there are 3 terms. Once we distribute, we can now see all 3 terms individually. But we need this equation set equal to 0. That's the only way we can solve a polynomial equation that isn't linear. We see the largest exponent is 2, therefore this is a quadratic equation. 36 needs to be moved over. So let's subtract 36. So on the left-hand side here, x squared minus 5x minus 36. Do I combine these two? Do I combine these? I don't combine anything. These 3 terms are unlike. An x squared cannot combine with an x through addition and subtraction. X squareds can only combine with x squareds with addition and subtraction. Similar with the x variable, it can only combine with other terms involving x to the first power. And this minus 36 is a constant, it can only combine with other constants or just numbers without variables. We have our equation through the distributive property and through our properties of equality subtracting 36, we now have our trinomial set equal to 0. This is what we want. Because now if we just ignore the equals 0 part, we have a trinomial that we will look to factor, and thus each factor set equal to 0, allowing us to solve for x. The leading coefficient here is 1. So we ask ourselves what two numbers will multiply to give us negative 36 that will at the same time combine or through addition to give us negative 5. Now, two numbers that multiply to give us negative, one of those numbers must be negative and one of those numbers must be positive. That's the only way to multiply to get a negative. So what are the factors of 36? We'll start with the easiest, 36 times 1, 18 times 2, 9 times 4, and 6 times 6. Can any of those combine in a way to give us negative 5? Of course, running through those possibilities, negative 9 and positive 4. They multiply to give us negative 36. They combine through addition to give us negative 5. Now, because this leading coefficient is 1, writing our binomial product, understanding that the first terms have to be x, because x times x is x squared. Now we use those two integers that we just found, the minus 9 and the positive 4. The factors are x minus 9 and x plus 4, because if you multiply these factors using the FOIL method, it will simplify back to give us this trinomial. Minus 9x plus 4x is minus 5x, minus 9 times positive 4, minus 36. So we correctly factored it. These factors equal 0, so set the factors equal to 0 and solve for x. If x minus 9 equals 0, then x must equal 9 because we add 9 over. If x plus 4 equals 0, then x must equal negative 4 by subtracting 4 on each side and getting x by itself. Now, of course, with these two solutions, you can always take them and plug them directly back into number 47 to confirm whether or not they are in fact the right solution. For number 47, if x is 9, we have 9 multiply 9 minus 5, which is 9 multiply 4, which is 36. So we confirm 9 will satisfy number 47. For negative 4, looking at 47, negative 4 multiply negative 4 minus 5 is negative 4 multiply negative 9. A negative times a negative is positive, therefore, negative 4 multiply negative 9 is positive 36, confirming our solutions to be negative 4 and positive 9. And for your homework, it may ask you to enter as a comma-separated answer, but you will just do, you'll type in negative 4, comma 9. Sometimes they may say, they'll give you two boxes, and they'll say enter the smaller answer here, enter the larger answer here. Well, the smaller, of course, is the negative value, the larger is the positive. We'll look at one more here, number 55. 55 here, we have the product of x minus 4 and x plus 5 equal to 10. Now, one thing we'll want to do here is we'll want to set the x minus 4 equal to 10, set the x plus 5 equal to 10, and solve. But I encourage you to do so and find solutions and plug them back in. You will not get a true statement. If you try to do this, one of the solutions you will get is 14. If you plug 14 back into that number 55, you'll get 14 minus 4, which is 10. You'll get 14 plus 5, which is 19. 10 times 19 is 190. That is not 10. So that is not possible. What you have to do for 55 is first multiply your two binomials and then get it set equal to 0 by subtracting the 10, thus allowing you to have a polynomial set equal to 0. Right now, this is not set equal to 0, and even if you subtracted the 10 and wrote this as x minus 4 multiply x plus 5, subtract 10 equals 0, that is still not a polynomial. You have to multiply through these binomials and then subtract the 10, combine like terms, you'll have it set equal to 0, and then you can factor and solve. Let's try this out. X minus 4 multiply x plus 5. X times x is x squared. If I do the outer product for 55, x times 5 is 5x. The inner product is minus 4x. Okay, positive 5x minus 4x, that's positive x when we combine. Lastly here, negative 4 multiply positive 5 is negative 20. This, of course, equals 10. So notice what we did here. We rewrote the product of our binomials as 4 terms where the inner and outer product combine to give us the positive x. Therefore, we have our trinomial set equal to 10. Now, this looks familiar, but now what do we need to do? We need to get this equation set equal to 0. We do so by subtracting the 10. If we subtract 10 from 10, this is going to give 0. This is going to give us 0. But I must subtract 10 from over here as well. When I subtract 10 from this trinomial, in order to do so, I'm really just subtracting 10 from this term. I'm doing it to the entire trinomial, but I'm doing it by combining the like terms. X squared plus x, negative 20, negative 10, that's negative 30. So I have my trinomial, in this case my polynomial, and more specifically trinomial, my trinomial set equal to 0. This trinomial is a quadratic, largest exponent is 2, where the leading coefficient is 1. So we ask ourselves, if this is factorable, and if it is, the variable x and x will go here for the first terms of our binomials, because x times x is x squared. Now, what times what is negative 30, such that they combine to give us positive 1? Positive 6 and negative 5. And the more you work at this, the easier it's going to get. Knowing your multiplication tables, those are small numbers. We have to know those. We have to know our multiplication tables, or else how are we going to buy our cheeseburgers at McDonald's, right? We have to know our multiplication tables. Positive 6 times negative 5. Positive times a negative is negative. 6 times 5, 6, 12, 18, 24, 30, or 5, 10, 15, 20, 25, 30. Gives us the same. It's pattern recognition. Positive 6 times negative 5 is negative 30. A positive 6x minus 5x gives us that positive x. So we correctly factor it, set each factor equal to 0, and solve. If x plus 6 equals 0, well, what number do we add 6 to get back to 0? We must be negative. A negative number plus 6 is 0. This is negative 6. And here we get x equals 5. So two solutions of negative 6 and positive 5. For good measure, let's go back to the PowerPoint and plug them into number 55. The original equation, just to confirm. But again, we're only using this original equation to confirm our solutions. Starting with the original equation, we need to rewrite it in that quadratic equation form. We need to, for all of our polynomial expressions, try to get it on one side of the equation, and on the other side of the equation, we need 0. We need the equation set equal to 0. Then and only then can we use our 0 factor property. So here for the solutions negative 6 and positive 5, let's plug them into 55. If x equals negative 6, then for number 55, negative 6 minus 4 is going to multiply negative 6 plus 5. And we want to know, will this equal positive 10? Let's go ahead and try that. Going back to the full view. X minus 4 multiply x plus 5. Does this equal 10 when x is negative 6? Negative 6 subtract 4, we get smaller. That's negative 10. Negative 6 plus 5, okay, I'm at negative 6. I add 5. That's negative 1. Negative times a negative is positive. 10 times 1 is 10. So positive 10 does in fact equal 10. So we just confirmed negative 6 is a solution. Let's check positive 5. So x minus 4 multiply x plus 5 equals 10. When x is 5, we want to know if this is true. 5 minus 4 is 1. 5 plus 5 is 10. We're multiplying these two values. 1 times 10 equals 10. So we confirmed what? That negative 6 and positive 5 are our solution. Thinking about our steps, we get the solutions by FOILing, subtracting the 10 because we have to get it set equal to 0, and we need to expose all of the terms that make up our equation. We do so by getting rid of those pesky parentheses first. Combine like terms if necessary, get the equation set equal to 0. Factor, set each factor equal to 0, and solve for the variable.